I don't like to talk.
Yeah.
All right, so let's see. Let's go into some anchor winless videos.
ER mistakes.
Say again?
Can
yes. Thank you. So quizzes go live as soon as the class starts. All right. So they're going to be in the same spot. You're going to basically go through. Today was quiz 1. The next day that we have a quiz is going to be quiz 2, and so on and so forth. The quizzes are going to stay up. You're going to be able to see all the answers you got wrong and right. All right. They're going to stay up for the foreseeable future. John, change your background. The other thing is you are going to be in, what do you call it? I lost my train of thought. They'll go out, basically they're live right now. So if you want to take a look at them, you can see them now. All right. So half an hour after they're done, technically it's half an hour to submitting. Basically what you have is the full capability for you guys to study right now. They're open book, they're open notes, all of these quizzes, you should be able to, it's not an aspect of that I don't want you guys to challenge yourself, is the fact is that I'm trying to give you the best ability in the worst case scenario of what we're dealing with right now. I'm not in front of you. You guys can't just stop by my office. We're teaching remote, all right? So use your notes, use the PowerPoints, and use the recorded videos that I have. All right, you can't use the recorded videos during the test or quizzes, but you can review them, re-listen to them, and if you have any questions, please come into the office hours and ask, and we'll re-explain it. All right, so let's go into today's topic, which is going to basically be watertight doors and anchor windlass. So this is a watertight door on board the Royal Caribbean. Basically what they're doing right here is a watertight door test for, they might have just installed it. They might be in Shipyard and they're ensuring that everything of their systems work, if it had any work done to it, all of these different things. All right, so take a quick look at this. So the big thing here is to notice a couple things. 1, it moves quite slowly. All right. 2, if we look here where my mouse is showing and here where my mouse is showing, those are both hydraulic cylinders. All right. So both of those are going to be pushing the door open or closed. All right. Some hydraulic doors will have 1, some will have 2. If you notice in this case, it has 2. All right. Here's the other thing is that watch this gentleman right here. All right. This lever right here is actually what's going to be controlling the door. So the door is now closed and he lets go. All right. That's the big thing when you're operating these doors. Because you may, like on our school ship, we don't operate these doors a lot. All right. You're going to go out onto a ship. It's going to be a big thing that you do sometimes. So when you're operating it, you have that lever and you're pulling it. The door isn't, if you hold it, and if you can just continue to hold it and held it so that it's constantly close, you're not going to bend this frame out. You're not going to cause really any damage. All right. If you watch him again, it's closed and he holds it for a good 3 count afterwards. All right. If it really mattered, he would have been sitting there and waiting and then closed it really and let go of the lever really quickly. All right. So another thing with it, with these doors, you will be doing inspections on them almost monthly. And you might even, when you're transmitting, like going transatlantic or transpacific or anything of transient, you might be actually having to go through these doors multiple times a day. All right. Your engine room might be on one side and you may be on the other with your control room. And in order to enter it, you're going to have to open and close these doors. All right. So when you do inspections, a lot of the times you're going to have to open up right behind this man right here. This is the whole enclosure. If you open that up, there's a hydraulic oil tank. You're going to have to check that there is plenty of hydraulic oil, that you're supposed to be at the right spot. The other thing that you're going to be looking for is if there's any leaks. You don't want leaks because then going through these doors, you can have problems, people slipping, stuff like that. And also, this is usually handled by the deck side as far as this consideration, but you're going to have to do a chalk test. All right, they'll come by. Usually the third mate will take care of it. What they do is that on the outline right here, there's a gasket. And what they do is they take a blue chalk, they run it down the whole edge of the gasket, and then they close the door, and then they open the door, and then they look on the inside here, and they're looking to see where the blue made contact. All right. And if there's spots where there is no contact, they might have to do some repairs or put in for a new gasket, anything like that. All right. So usually sealing, for some reason, that's the deck side. All of the hydraulic, everything of operation, engine side, even if it's in the engine room and everyone's taking care of it. These are just the ways that I've seen it being split up. All right. But it can go either way. So watertight doors, very important. They save ships. The other aspect is that when we look at watertight doors, what are they actually physically doing? What are they supposed to be doing? And if you know, just unmute yourself and start talking.
Don't they like compartmentalize the ship so that the water doesn't continue to flood throughout?
Exactly. So you have watertight bulkheads and compartments. All right. And basically what you're trying to do is you're trying to take the ship and you're trying to split it into different sections, of which basically if anything happens in one section, you can close these watertight bulkheads and these watertight doors. And now if one section floods, it won't affect the other sections. All right. So you can have multiple all the way across the ship. Come on. See how this person, if he has to transit all the way across the entire ship, especially on cruise ships, they actually have what's called like main highways. And the main highway goes all the way from the bow all the way to the stern, and it's a direct line. And that's how cruise personnel can get to and from on the ship easily. All right, but they all have watertight bulkheads. So you could be in a spot in an engine room or on the deck compartment. If you go on a cruise ship, you'll end up more going through these, where you have to go all the way through a couple watertight bulkheads just to do one round and then come back all the way through them all. So you could be stepping through them multiple times a day. All right. So
I have a question.
Yes.
This is kind of simple, but like, would there ever be a situation where they're completely closed and locked, or is there always like a way to bypass it?
So there isn't really a lock. Like, it's not like one of those things where you're going to be sitting here and, you know, you can't operate them. There is things where you have, like you can see right here where my mouse is going around, there is a hand pump there. Others are what looks like here on the other piece. You see this bar right here, that's a hand pump. And that allows you to open or close it with no power. All right.
All right, so it'd never be like, oh, like we have to, like you're the only guy left in this compartment, but to save the ship, we have to trap you in there. I know it's kind of like obscure, but I was just wondering. There
is spots where they're not going to close you into a compartment. All right. Now, closing watertight doors, and they're going to do them in emergencies. Watertight doors get closed from the bridge, at the location, and one deck above. Those are usually the three locations that you have. Now, that being said, they will be able to be closed from the bridge, and you will be able to open and close them at location. All right, so if you are the one stuck in that compartment and the doors are closed, you could open and close them. You should have enough hydraulic oil in there to be able to open and close them, even if you don't have power. All right, so as long as you have power and there's not hydraulic oils that's leaked, there's no way to actually physically like close the blast doors and lock them kind of mentality. All right, you will be able to go through them, and you will be able to get basically to get through it as long as you can pump it with a hand. All right. Now, if you are in a different type of water type door, which is manually done, then there's no hydraulic oil that's going to help you open these doors. All right. Like we could see here, this is a one cylinder, one piston pump. All right. But if you're in like a submarine scenario where it has the submarine door where you have to actually physically close the door, Let's see if they should have. So that's a watertight door right there on the left. All right. Now there's two dogs right there that will close the door and do almost the same thing as this hydraulic watertight door. All right.
A wet water line.
Now, let's see. Let's go through this. Nope, it doesn't have it really what I want. So that type of watertight door, due to the pressure of what is happening on one side or the other, you may not be able to actually open that door. All right. So that's basically watertight doors. The big thing that you want to see you do is just don't go through them while they're opening or closing. Just wait the 5 seconds that they go through. The other aspect is that if they are closing and you're on the wrong side of it, call on the radio, stop the door from going. You should be able to take over manual control there, all right, and fight it. So if the bridge is trying to close them and you're on the wrong side of it, you should be able to go to the lever and go to the open and override what's happening. All right, so the other aspect, let's take a look at anchor windlass. Oh no, it's going to put an ad to everybody. So this is a Navy ship who lost control of their anchor windlass.
Number 3, the USS Tarawa dropped anchor at sea, but things get a little out of hand.
Watch how fast and how much they let of anchor. They actually lose the anchor here. God, it falls off the ship. You see the two gentlemen right here are working the brake. So you have the warning shot and then the danger shot. Warning shot means start getting out of the way. Danger shot means get the hell out of the way. Because that thing is coming flying and that anchor's gone. It's not attached to the vessel anymore. And then we'll actually watch this one. This one's usually the more famous one you've seen. This guy in the yellow is operating the brake, and this actually will catch on fire due to the heat that's produced by the brake.
Perdona,
Yes.
¿puedes decir cómo llegar a...
Eventually, these guys just run away. Yeah, see, they start running. And they're getting into the safety area where those chains won't be able to hit them. And that's another anchor chain gone.
Number 1.
And then this one's my favorite.
Was accidentally dropped directly onto a tugboat.
Is that like a huge problem? Like, obviously, yeah, losing your anchor is a problem, but like for the company, like, is that a huge expense?
Yeah, anchors are a very expensive fix when you lose them. Sometimes they'll try and go get them, but if it's too far down, it's gone. There's nothing that they're not getting it back.
Is everything like I know everything's probably kind of expensive, but like, are those more expensive compared to like other types of stuff that you usually have to fix on a ship, or is it more like a logistical thing?
Say again?
Is it more of like a logistical problem, or is it literally like, wow, that's like a $50,000 piece of equipment, or is it both?
I mean, it's going to be an expensive problem. It's not like scrap the ship expensive. It's just one of the issues that they're definitely going to go try and get it, but if it's too deep in the ocean, there's no way you're going to get a salvage ship to go out there and find that. And then usually when that's lost, it's usually a huge amount of damage is done to, I mean, you can see what happened to the anchor witness that actually was there. They're gone. They are totally, one was caught fire. Others have almost completely disintegrated with what's happened. And you can actually have balls of chain that could be coming up that wasn't laid properly. Huge amount of issues that could be unforeseen at that time. All right. That could be like lose your job category of bad. You won't be invited back.
Yeah.
So I hope you guys never see those things. I hope you just keep the video with that. It's the idea is that there is things that you could be going in and seeing. I've had friends who have seen it and lost anchor chains and lost wires and stuff like that, and seen wires explode like that. So, always be in control of what system you're operating. All right. Let's go into watertight doors and systems like that. Share screen. Getting better at this. We're going to go to bring the chat up. And then if you guys can leave your cameras on, I would appreciate it because it helps me that I'm not just talking to a blank wall. I'm physically talking to you guys.
This will be up by the end of the day.
Say again?
And this will be up by the end of the day.
Yeah, it's going to be up by the end of the day today. I just have to put it up. All right. Same with the lecture. It takes a little bit to compile and then also edit out the fact that the first few minutes are going to be quizzes and stuff like that. And then once all that's done, I'm going to be uploading them to YouTube. All right. But these will be going up. So let's talk about shipboard hydraulic systems. All right, so we have constant flow type systems that we're going to have. They're basically going to be a gear or a screw type positive displacement pump. Their motor or hand driven delivers constant gallons per minute. The resistance to movement deters pressure developed. And then examples are watertight doors, hydraulically operated hatch covers. All right, so we have a constant flow system. Here's a watertight door. All right, right here is basically going to be our open and closed system, basically our pump. Right here, this whole piece right here is a piston. And then we have our cylinder, these gray pieces on the wall. All right, now these pieces that I'm circling, not this, these 5 pieces that I circled, what are they? What would they be? If anybody knows, please shout it out. Say again?
Check valves.
Those are your check valves. All right. So, like I said, we were going to do close. So right now we're in an open scenario. So closing is coming through. We're going to have a high pressure that comes through. We get blocked here, but we're going to have flow in this direction. So that check valve opens. We are going to pressure the entire system. So we have a higher pressure. If you notice, this pushed our return valve into an open position. All right. Now we have a high pressure on this side. So this side over here is high pressure. Then we have a counterbalance valve. So as soon as that high pressure starts to put pressure down on this side, we are going to have flow. It's blocked here. All right. But we have a downward force that's going to be on the counterbalance valve, and we're going to have flow going in this direction. All right. So as we see, this is pushing downwards. Higher pressure is over here. The door opens. We add flow that's going in this direction. We get blocked here. All right. Then we have flow that comes through here. We can't go in this direction. It's blocked. So then we have to flow only in one direction. So it's going here. And we're not going to be able to go in this direction because of the higher pressure here. All right. That's coming out of the high pressure pump. So if we're sitting in a closed position like we are now, and we want to open, we're going to open. We're going to put a high pressure down on this side. All right. This side becomes our low pressure. Again, we can't go in this direction. It's closed. All right. So we have only flow in this direction. We get a high pressure along this whole line. It moves this shuttle valve right here. All right. So now we're allowing flow in that direction, but we are closed here. We allow flow in this direction. We get a high pressure, and we're going to open our door. So the high pressure moves the piston, squeezes out all of the hydraulic oil, comes in this direction. Again, look, we have a blockage here. All right. There's going to be no ability for it to go any other direction but here. So it flows through here. Again, it's blocked by our high pressure, so it only can flow back to our pump. All right. And that's how we're having a constant flow system. Again, this is a gear or screw type positive displacement pump with a motor or hand driven delivers constant gallons per minute. So resistance to movement determines pressure developed. So that is the resistance to movement. All right. Betting people. So with a constant pressure system, so this is a constant pressure. So these pumps are always on. So this is when you hear like backhoes, or if you hear cranes where they have like that loud high, like that loud high pitched, and then all of a sudden you hear a backhoe open, like it just starts moving, and then the pitch dives down and you have movement and it sounds a lot nicer to the ears. That's what's happening here. It's because the pump is always on. All right, often found in systems where multiple BN devices are actuated in various combinations, powered by a single AN device. All right, remember our ANs is just driven by hydraulics. So we have one pump that's going to be hydraulically driving, that's going to be driving all of your BNs. So we have our pump here, comes out. So if we have our swing drive motors, This is like an instance where you have a joystick where one way or the other is going to drive what's happening here. All right. This is all going to be driven by a joystick, along with these, and these. All right. Each one of them is going to be a joystick. And when you go back to center, it's going to center it. So now you're going to have a no flow scenario. There's nothing flowing through there. All right. And then you go the opposite direction. Now you have a different flow. And that's the same with all of these. These are just 4 examples of what could be going on with a different crane. But it's all done by one motor, one drive, one pump that is pushing hydraulic oil through. All right, so a demand type system. So flow rate determined by operator or control system command signal. All right, so the resistance to movement determines the pressure developed. Often utilizes axial or radial piston, variable stroke pump as an AN device, and examples are steering gear and anchor windlasses. So the flow rate determined by the tilt box position, and the pressure determined forces on rudder, speed, draft, sea state, etc. So that is a steering gear system that is actually developed by speed and pressure. But a little bit more of a better understanding of this is an anchor windlass. So you have a constant speed motor, all right? And this is an axial piston pump. That is what's driving. And then your driven end is going to be another axial piston pump, all right? This tilt plate here is going to be variable. It's going to be controlled by this joystick. And either direction is going to change your tilt plate, all right? Whereas this tilt plate here is constant. It will not change. So it's a fixed tilt. You have your electric brakes, you have your Gibson's head, you have your Wildcats. So you go in one direction, you're going to have high pressure liquid go into your driven axial piston pump. All right. And you're going to flow, and basically it's going to control your direction. All right. Now we flip it and we go in the opposite direction. Now this tilt plate changes direction down here. This tilt plate is still the same, but we're going to go in the opposite direction now. All right. That's the big thing that we're going to be doing. We are controlling our direction of our driven via one tilt plate. So keep in mind what we're looking at with these axial piston pumps. They're split almost in half, all right? Each side, and as they spin in one way or the other, they're spinning in this direction. This side could be suction, and this side could be discharge, all right, depending on which way the tilt plate is forming. And this is for the driven end. Driving end, sorry. So this is driving with your hydraulic oil. All right, so this is spinning in one direction via that. But with a fixed end over here, because the tilt plate is fixed, and this end over here can change its suction or discharge, this end over here can change direction, so it can go in either direction depending on the fluid coming out on one side or the other. All right. So the pump rotating at a rated speed, the tilt box is at 0 stroke. So no movement right now in any hydraulic fluid. We are just constantly spinning. So that's that high pitch that you hear when these are moving. All right. So no fluid is pumped to the motor. The motor is not rotating. All right. With no hydraulic fluid moving, we are not moving our motor. Now, we have a tilt plate, and our tilt plate is now going in this direction. We are now going to have movement of hydraulic fluid. All right. This is still a pump. So the pump rotating at a rated speed, the tilt box is at maximum stroke, maxing the fixed tilt of the motor. All right. Fluid is pulled to the A end, near side, and delivered to the B end, far side. Motor rotates as the pump speed in the same direction. All right. So one side of our motor, because they are connected, it's sucking in our fluid from our motor. All right. Our driving end is physically pulling in hydraulic oil on one side, and that same hydraulic oil is being discharged to the opposite side, and then it's doing the same thing. And that's how we're going to change our direction, by only having a motor that runs in one direction, just by changing this tilt plate over here. All right. So we can control the speed of which we move our motor, our fixed tilted motor over here. And we do that by how much of an angle our tilt plate is at. All right. The pump rotated at rated speed, the tilt box is at half stroke. It delivers half the volume to the motor per revolution. So in doing so, it's only going to be able to take and give only half the amount, because we are at half the angle we were. So these pistons are only going up and down half the distance instead of their full distance. Okay? The motor rotates in the same direction as the pump, but at half speed. Oop, there we go. Sorry about that. Remember, we are not changing the speed of our driven end. This is driven by a motor. That's our electric motor driving it. It's going to be constant speed. But the way we control our driven motor is via how much hydraulic fluid is going through it. All right. Now, we rotate our tilt box to the opposite direction. Pump is rotating at a rated speed. The tilt box is at maximum stroke. It's the opposite of the tilt motor. The fluid delivered to the B end, remember this is the B end, near side, is pulled to the A side, far side. And the motor rotates at a pump speed in the opposite direction. So we have, instead of going in one direction, we have, because of our tilt box on this side has changed sides, we have now made one side of our pump and open one side of our pump, our suction, and the other discharge. Whereas with the other, it was the opposite. This side was a discharge and this side was a suction. So that's how we change the direction, is via this tilt box, where we keep our B end tilt plate the same. We only have one variable. This is the one variable that we have. So any questions on that before I go into a few minutes of review on evaporators? No questions?
How does the second motor, when it's rotating in half speed, how does that help? As if, like, if it wasn't rotating at full speed?
So it's one of those things where if you would want how much control you want to have. All right. So if you're coming up with anchor windlass and you have your joystick, you don't want to be at full blast the entire time. It's like if you were in your small boat and you're coming up to the dockside, you're not going to come up to the dock at full bore. All right. You want to have less speed, more time to react, more control. Okay. Any other questions? All right. So let's go into close that. Weekly lessons. Freshwater generation. And share the screen. All right. So, distilling plants. Switch your minds over to evaporation. Remember, when we talk evaporation and we're making fresh water, we are looking to create fresh water and distilled water as efficiently as possible. All right? Everything that we do, yes, we can make a very easy distilling plant with no efficiencies, no complications. And you know what? We would be really bad. We would not make very much water, and it would take a huge amount of energy. But because we are not entering a feed water at 55 degrees, and we are not making our vapor have to boil at 212 degrees Fahrenheit, we get a lot more water, a lot shorter amount of time, because you know what? This distillate over here is going to go up right against the bulkhead, and the seawater on the other side is going to be at 55 degrees, and it's going to cool that distillate off no matter what. We might as well use that heat and put it into our feed water. All right? You don't want to lose it. So, again, that we want to talk about, our high pressure is anything at an atmosphere. 1 atmosphere is what we're sitting at right now. All right? 14.7 psia is equal to 0 psig. Remember, it's where they're taking their 0 points at. All right? And where they're boiling water is whether it's either Fahrenheit or Celsius. So anything above 1 atmosphere is high pressure. Anything below it is low pressure. It's under volume. That's when we talk inches of mercury, or it's commonly known as just inches. All right? And when we talk about contaminated fuel, contaminated evaporators, all right, they are under a high pressure, and they're under a high pressure so they don't get contaminated. And if they do, it's because of what happens when these systems aren't calling for heating. So if you're not fueling up your ship and you're not moving oil from one tank to another, you're not going to be heating up these tanks. So when you're sitting there and you're in a tank and you have all these lines coming in, and you have basically, this is your fuel oil tank, and you have a heat exchanger where all of these lines here is steam at that point. High pressure steam at a certain point is high pressure. It's 40 psi. It's going through here. Well, you know what? You close this valve and you're now not allowing any steam to go through. And this fuel oil will seep into it. And then when you go the next day to move your fuel oil and you turn this on to preheat your, to heat up your fuel oil, now you have contaminated fuel going, contaminated water basically going into your drain cooler, and that's when it's going to be present in your contaminated drain tank. All right. So again, a float switch here, it's going to operate, it's going to pull in from your contaminated drain tank so you can peer in and look in. It's going to be at atmospheric here. This is where it's going to be at atmosphere. All right. That's the point of a high pressure contaminated evaporator. You do not want any of these systems to go anywhere near your boiler. All right. Now, again, here's a submerged tube type. Submerged tube type, yes, Obviously, it has a tube's nest. It's in the name. But let's look at it closer. What we're doing is 130 degrees Fahrenheit. 130 degrees Fahrenheit is what's entering it, but it boils at like 142. All right. What we're doing is every single one of these steps, our condenser, our distillate cooler, our air ejector, every single one of these things is heating it up from a feed pump of 65 degrees Fahrenheit that's going to get all the way to 130 degrees. And nothing that we've done has been a direct actual heating. All right. But when we go to our flash evap, our big difference that we have to look at is this temperature right here. We remove the tube's nest. That's gone. That's why it's called a submerged tube type evaporator. But here's what's going to happen is we have all the water instead of some of it being lost. It's going into our feed water heater, so we're preheating it before it even goes into the system. And this is the big number change, 172 degrees. It's entering hotter than what it needs to boil. And this feed water, the reason it's not boiling until it goes through this wall right here is because right here, it's under like 60 PSI, about, depending on what feed pump you're using. So at 172 degrees, it's not boiling. It's not even close. But as soon as it goes through this wall and pops out into here, it's no longer under pressure. It's under a vacuum. And at 24 inches, it's going to boil at 142 degrees. So that change of phase is what's going to take all of this extra heat and why it's not 172 degree vapor. All right. Like we said, it can't physically exist there in that state. It has to be steam. It has to turn into a vapor. All right. So that's just some real quick going back over evaporators and the main difference that we have to look at. All right. Yes, it doesn't have a submerged tube, but look at what's actually physically happening. Broaden what is going on in this entire system. It's not just what's in the shell. If it was, then we wouldn't be even remotely talking about what's going on here. We would call it an evap, and we know it makes water, and that's all we would ever care about. All right. So that's a little bit about evaporators. I'm going to try and get some sort of, since we lost a week of classes and we can't do reviews that whole week, I'm going to try and sneak in reviews when I can on some things that I know I've seen you guys to mess up a little bit more in your classes. Oh man, my contact's drying out. So basically class is over, no quiz Monday. All right. But still come to class. If you guys have any questions about anything with class, let me know. I'll stick around for a few minutes. I have to get going with, I have a test to give at 1:15 for somebody for a makeup. Now, I am going to be posting 2 videos to Blackboard, and they are just some settings that you can change on your router if you're struggling with your internet. All right. If it's coming in and out, I've done them personally. I suggest not doing them right before you go to class. I suggest maybe messing around with it on the weekend. But always, if you can connect to your Wi-Fi router via an Ethernet cable, that will help you out, all right, with these classes, so you won't have disconnect issues. Or if you have slow internet, these videos will help you. I've done them personally to my router. So, you know, you're all trained to be engineers, and other people are going to be tech department marine ops. You're expected to know more, but also you should be able to figure these things out. But these videos should help you with any settings that you want to mess around with and hopefully help you out. Okay. That is it. If you guys have any, the other thing is office hours and this class. Office hours is basically going to be Tuesdays and Thursdays, 10 a.m. to 12 and 1 p.m. to 3. All right. That gives me an hour for lunch in the middle. If neither one of those work, let me know. We're all stuck at home. I'll just turn on my computer and I'll help you out. All right. But just email me. You know, basically come into the Zoom chat. It's going to be open up on my computer, and just basically say like hi, because it's just going to come over my speakers. All right. And then give me a few minutes. I'm probably gonna have to turn on my microphone. All right. Other than that, stick around if you have any questions. I'll keep this open for a bit if you have anything.
We got an email talking about finals week. Are we coming back in, or are we just doing them online?
No, so we're not coming back in. That's not happening. Okay. Mainly because I know international students have already been assured that they're throwing a huge amount of things up in the air right now. Professors have the option to do in-person testing, but even coming from my boss, he's seeing how that's not even going to be physically possible, even to force you guys to come in. So expect my final to be online.
And the when's the next exam?
Next exam is going to be, we have 3 more electricity lessons. So let's see, we have tomorrow, next class 30th, 1, 2, probably the 8th.
And it's going to be like what we did for the quizzes. We got timed, and you're just going to make us take it like that.
Yeah, that's basically what it's going to be. It's going to be 50 questions. You're going to have the hour and 15. It's going to take me a little bit to do it, just to figure out the aspect of it, so that way you guys can still have the pictures, everything like that. But like I said, it's open note, open PowerPoint. The only thing you can't use is another person, and you can't just be watching my YouTube videos in the background. All right. That's the other thing. YouTube channel is up. It'll just be posting. I made it like a professional YouTube just for you guys. So it has the 10 a.m. lesson lecture and the 11:30. So feel free to watch them if you want, but it's the exact same lecture. So if you missed it, you can rewatch it. All right. And if anybody has any issues with their internet cutting out, it happens. Take a picture of it. Plenty of people already been doing that with issues that they have and emailing it to me. All right. We'll work something out. Don't freak out. If you missed the quiz because of it, you already heard what happened to another student that it closed out on her. I just reset it right away. I have the power to do so. All right. Any other questions? Throw them at me. You guys all good? Just closing out.
When can I see my quiz? Because I tried and I cannot see my answers about quiz.
All right. So you should be able to see them now. It should have been, I think, 12 o'clock. So why don't you refresh the page?
I will try.
Yeah, just take a look at it and let me know really quick if you can.
I'm looking right now.
Edit the test options. After due date, 3/25 at 12 p.m. It should be showing everything. Can you see it? Have you tried refreshing or?
I can't see it. I'm clicking on quiz 1.
Okay.
Am I making it correct?
Yeah, you should be in quiz 1 and you should be able to take a look at it from there.
After I click quiz 1, there's a begin button.
Have you taken it yet?
Yeah. I don't know why. After I click the begin button, there's a button that says, it says, we will attempt. And when I click to view all attempts, all I can see is my grade.
Display after at 11:30. All right, do me a favor. Go to the bottom of your Zoom, and you should be able to share your screen with me.
Oh, yeah. Oh, but you are disabled the screen sharing, it says. Host disabled participant screen sharing.
Yeah, let me see if I can get.
I said yes.
All right. So go into the class.
For the module, exams,
Okay.
quiz 1.
Here, don't click through too quickly. All right, let me see. Go to my grades. Let's take a look.
You can do it.
Yep. No one else is seeing this, right?
I don't know.
Okay.
Yeah, this is the only thing I can see.
Did you take the optional quiz?
Yeah.
Were you able to see the what you got wrong with it?
No.
No?
No. Can we look at that? I didn't know that.
Yeah, you should be able to look. All right, let's go, because you could do it quicker than me. Why don't you go into the modules, exams, optional quiz, and see if you can look at those. Hey, if you click the blue bar on the left, you can be able to get the whole.
This one?
So this blue bar over here.
Oh, all right.
So you pop that out, and you can actually go to modules really quickly.
Oh, yeah. Exams?
Yep, go to exams.
Optional quiz?
Yep. See what happens when you click that.
I can see.
Press begin and let's see what goes on.
Yeah.
Okay. All right, let me go from there. All right, and I'll take a quick look and play around with it. And it should be, but I don't know why. All right.
I don't know. I can try it for tomorrow and then let you know if it is working or not.
All right, everything's clicked on it. Try again. If you have somewhere to go. can go if you want to.
Can you see my screen?
No,
I
not
can-
anymore. I closed out of it.
So modules, exams, quiz 1. No, still the same thing.
All right, I'll have to take a look. All right.
All right.
Let me mess around with it. I'll let everybody know if it's working or not. All right, but I appreciate you letting me know.
Thank you. Have
All
a
right.
good
Have a good day.